Complex numbers. So today we are going to have a look at complex numbers. Complex numbers, the normal numbers are 1, 2, 3, 5 over 7, 1.5, 3.14, 21 over 7, any fraction. These are known as normal numbers. Complex numbers are numbers that has two parts. One is imaginary part and another is a complex part. Real part, and another is an imaginary part. How do we donate the complex number? The complex numbers are donated by Z. Yeah. So Z is usually a notation we use to define the complex numbers. Now, complex numbers are made up two parts. This is a real part, A1, and that's a B1 is a part that is imaginary. This J, sometime you will see J and sometime you will see I. So this is how we represent the complex numbers. Now these are Z2, now which is A2 plus B2J, where A2 is a real part and B2 is a imaginary part. The imaginary part will always be attached with an I or a J. Now this I or a J is written um, is written like this, and this stands for iota. The I has a value. So I might be using I or J, they are same thing. In your calculator, it is I, so I will use I. So I has a value. We will discuss the value in a minute. What is the value for the I? Now, if you want to add a complex number, it's very simple. You just go for the real number, which is A, with another real number, which is these A's, and you just add these two. And then you just add the complex numbers, the imaginary numbers, B1 and B2. And this is how you just do the addition. Subtraction is again very simple. Yeah, Z1 minus Z2. So you subtract the real parts plus you just subtract the imaginary part, and that's how it works. So now next part we will do some questions, example questions on how to add and subtract the imaginary numbers. Okay, let's imagine we got a number Z1 which is 13 plus 5i or j, doesn't matter. Then we got the Z2 which is another complex number which is 8 minus 2j. Okay, so our question is to find the Z1 plus Z2 and Z2 minus Z1. So first we need to identify the real part and the imaginary part. So this is the real part in this one. This part is the real part. And this part is also the real part. And the imaginary part, this is the imaginary part. And this is also the imaginary part. Okay. Now to do that one, the way we look into solve this one, let's say we got a Z1, which is 13 plus 5j. And we got Z2, which is 8 minus 2j. And we are supposed to add them. So let's add them. If I add Z1 plus Z2, that will be a Z1 plus Z2 here. And now I need to add them. 13 plus 8 is how much? Yep. Okay. 5 minus 2 is how much? 3j or I, doesn't matter. Yeah. This is the answer. This is how we do the addition. Now, if we need to subtract it, how do we do the subtraction? Subtraction is, there is one extra step in subtraction. So we write that one again. Let me use a red color. So let's say I got Z2 should be on the top because it's Z2 minus Z1. Z2 is 8 minus 2j, or I, doesn't matter, and z1 is 13 plus 5j. When you add the complex numbers, it's straight away you just follow whatever sign is there. But now, what sign is there? There is a plus, positive sign here, isn't it? And there is also a positive sign, because when there is no sign, it's positive sign. You do one extra step. The step is this: you change the sign. The first thing is because you're subtracting it. So when you're subtracting, you change the sign. Whatever sign is there, you change it. You change this sign, and you change that sign. Now you focus on the black one. Z2 minus Z1. So write it down. Z2 minus Z1 equals 8 minus 13. You look at the black sign now. Minus 13. What's 8 minus 13? Minus 5. Yeah. Minus 2 minus 5. Minus 2, then again minus 5. So look at the number line. You are minus 2, and then you move minus 5 more. So that's minus 7 now. But it comes with a j or an I. This is how we do the subtraction of a complex number. Okay, now why do we study complex numbers? If we don't study complex numbers, we can't watch Netflix. Why? All the electricity works on the complex numbers, conjugates, and that thing. The electricity, when it comes from one grade to another grade, they are out of phase. To make them in phase, there is a complex number processes, complex mathematics happen that utilize a complex number. So you can't have electricity if you don't, because complex numbers are numbers which has a magnitude plus the direction. But why the scientists come up with that one? Because they were stuck. When they were calculating the square root of 1 in the calculator, it was giving them error. No one knows what the answer was. Because of this limitation, they were stuck to do further maths, further calculation. So they were not able to solve a lot of problems. Then they agree. They said, okay, because we can't solve it, but it is something, you know. So they call it like iota or I, imaginary numbers. So if the question is like square root of 4, you know square root of 4 is a 2. But then if it's square root of minus 4, so if you put that in your calculator, it's going to give you error. Yeah. But if you change the setting in your calculator as a complex mode setting, it's going to give you this answer, 2i. Yeah. If I is that, I need to square the I. So let's square the I. I'm squaring both sides. So I square is going to be, that cancel out, this and this cancel out, minus 1. We have the value for the I square, but with I, it's a square root 1. Now later on, we are going to do Argand diagram, which is a vector diagram, kind of vector diagram, which tells us how the system, the electricity flows, what's the direction and magnitude of the vector, and so on. So we will utilize the complex number knowledge there. It's very important in engineering. When I say very important in engineering, let's say there are two complex numbers, Z1 and Z2, and what we're trying to find out, we are trying to find out Z1 minus Z2. So we are subtracting the complex number. Yeah. When you subtract the complex number, the thing you do is you write the complex number. We're doing Z1, so we write Z1 first, and then we write Z2. Yeah. So just draw a line straight away. Yeah, you're subtracting them. So whatever sign is there, you change it. So there is a invisible positive. I'm going to change it to negative. There is a positive. I'm just going to change it to negative. Yeah. Now you don't look at the red sign at the bottom. You look at the blue sign at the bottom. So this is what you're going to do. 3 minus 2. What is 3 minus 2? 3 minus 2 is 1. Now this is 10 minus 4. 10 minus 4. 10 minus 4 is positive, still positive because 10 is bigger. Yeah, 6i. And this is your z1 minus z2. Multiplication of a complex number. How do we multiply the complex number? Now imagine we got a complex number z1. Z1 is 5 minus 2i or j. Z2 is 2 plus 4j or I. We want to find out z1, z2. When they say z1, z2, it means you have to multiply z1 times z2. We don't put a dot or multiplication sign. So if you see z1 dot z2, it says multiplication. If there is that one, that still mean multiplication. Or if it just z1, z2, that still mean multiplication. Yeah. Okay. Now, how do you multiply? To multiply the complex numbers, this is what you do. You write down z1 first. Dot z2. What is z1? You write it down. I'm just going to write I rather than j. Then dot 2 plus 4i. Once you have written it down, you need to multiply. So we use the method FOIL method. First, outer, inner, last. Yeah. So we use the method called FOIL. First, outer, inner, last. So what I'm going to do is, this is the first thing, 5, and this is the first of the second bracket. So I will multiply these together. 5 times 2 is 10. You write it down 10 here. The signs are very important. Now then you do outer. This 5 is the outer of this bracket, and the 4i is the outer of that bracket. So now you multiply this with that one. Now 5 times 4 is 20, and it's a positive 20 because both are positive. So positive 20. But there is an I there as well. So I'm going to write positive 20i. Now the next bit is you go with the inner. This is the inner and that's the inner. So you multiply these two. This is minus 2 and that's a 2. So that's going to be, sign is going to be negative. Negative 4i. Now the last one is the last. This is the last of the first bracket and this is the last of the second bracket. You multiply them together. Minus 2 and plus 4, that's going to be minus 8. And I times I is I square. So this is the half of the multiplication done. Then we need to simplify it. To simplify that one, if we have a look, these two numbers, these one, they are pretty much same. It's 20i minus 4i. So 20i minus 4i is going to be 16i plus 16i. Why plus 16? Why not minus 16? Because the bigger number has a positive sign. This 10 I will copy as it is. And that is a minus 8. I got minus 8. But I square, we know the value of the I square. I will show you two methods of doing that one. The first method, whenever you got I square, instead of I square, you just write minus 1 because I square is minus 1. How come? How come? Because imaginary number is this, is I. And if I square both sides, that will become a minus 1. So I square is a minus 1. This is my first method of doing it. I will show you the second method in a minute. So I got 10 plus 16i minus 8 times minus 1 becomes a positive. So minus 8 times minus 1 becomes a positive 8. Yeah. And now if I can see I have two real numbers. Where